Hello world, this is Sean McBride, and today I want to write a little bit of COBOL. The past couple of months I've been investigating languages outside of my C and C++ specialization, and COBOL has struck my fancy as of late. So COBOL is a very unusual language. One of the most unusual things about it is that it is very structured. And by structured, I mean like the same sort of organization as what the United States Military Academy taught me, with like the 5 paragraph operations order, where you have a very specific structure and certain data is supposed to go in each paragraph. You know, that sort of structure is what carries forward in COBOL. And so to write a COBOL program, at the top level, we have divisions. And the first one is called the identification division. The main thing that goes in the identification division is the program identifier. You can kind of think of this as like the identifier for like a callable symbol in C, like a function. We do this by writing the keyword program ID, and then we can write our program name, which is going to be hello here. And then at this point, this is like a legally valid COBOL program that does basically absolutely nothing. Okay. So if we want to be able to do things, we want to add another division. And I'm going to go ahead and skip forward and go to the procedure division to do our hello world. A procedure division basically is the section for defining what COBOL considers procedures, which are basically equivalent to functions that take no parameters and mutate shared state. So we can add a bunch of statements here, and those statements are grouped into what COBOL calls sentences. Sentences are grouped into this concept of paragraphs. Paragraphs are grouped into sections. Sections fall under procedure division. But we can skip a lot of that, and we can just basically write a single sentence containing a single statement. Our statement is going to be display hello world. And then we make that a sentence by putting a period. In modern COBOL, typically you try to group multiple statements into a single sentence, and then you might have a trailing dot here to show the endoscope. Okay, and so we can see over here on the right that we're displaying hello world. So just kind of looking at this, we can kind of start to see why this is very English. And so, for example, if you wanted to modify how display operates, like for, let's say, we want to split this into 2 different statements. Okay, now it's broken across 2, and let's say we don't want that new line. I think it's display with no advancing. There we go. Now we're back on 1 line. And our default here is that we print to the console, which is kind of COBOL's take on standard out typically. And that's the default, but we can be more verbose about that and say upon console with no advancing, or upon console. Yeah, look at this. So English-like. Okay. So that's the idea here. We write a sequence of statements here, and we can do things in the procedure division. One of the key limitations is that you are not allowed to declare variables, and the term for a variable in COBOL is a data item, because clearly a data item doesn't belong in the procedure division. That's for procedures. Data items belong in the data division. And so what we end up having is very strict separation of basically declaring all the data up front and then manipulating that data in procedures in the procedure division. Okay, and the type system of COBOL is going to seem very strange to a modern programmer, and I will get into that a little bit. The key thing is we have our data division, and then we have multiple sections within that division, and that kind of corresponds to the lifetime of data. So we have, for example, the working storage section, and that's basically our static data. We also have our local storage section, and that's more like an automatic lifetime. So we have our program identifier here, and a program can actually be called equivalent to a function in C. And if you want to pass parameters, you have the linkage section. And that basically allows you to define the signature of parameters that you pass and return when invoking a subprogram. Okay, so let's go into working storage section, and we're going to basically declare a scalar. Let's declare a scalar called U10, and this will be a base 10 unsigned digit. The way you define a type in COBOL is through what's called a picture clause. And it's sort of like a regular expression or something like that. It's a specialized kind of DSL for types. And I can just put like a 9 here and then a period to end that sentence. And what this is basically declaring is an identifier U10. And what this is able to store is a single decimal digit. And I can initialize this through value stu1. Okay. And then down here in the procedure division, I can access this display U10. And over here on the right, we can see that it's got that initial value of 1. We've got a lot of very English statements to be able to manipulate the data. We can do subtract 1 from U10. Let's move that above the display. Okay, now we've got 0 here. And let's go ahead and show what happens when we subtract 1 from 0. So it looks like we kind of bounce around between 0 and 1. That's interesting. I'm actually not totally clear why that behavior occurs. Let's go the other way. So instead of subtract 1 from, we could do add 1 to U10. Let's see what that ends up looking like. All right, so our initial value is 1. Now we're 2, 3, 4, 5, 6, 7, 8, 9. All right, so if we add up, it looks like we wrap around. Which kind of suggests that if we collapse these down and we've got a single digit of initialized to 1, if we add 10 to it, basically our least significant digit ends up still being 1. Yeah, so you can kind of see that wrapping behavior. Yeah, let's take a look at that subtract again. All right. So we initialize our unsigned single digit to 9 now. Subtract 1 from U10. Okay, subtract 9 from U10. Subtract 10 from U10. Interesting. Yeah, it seems like it's kind of like a negative number, but with the negative dropped is what it seems like it's behaving like. Yeah, so that kind of begs the question about signed numbers. All right, so to get a signed number, we can basically add an S in front of our 9, and that gets us a single signed digit. So that should express negative 9 to 9. All right, so we are going to change U10 to S10. All right, and now we can basically see that we have our negative here. So it seems like the behavior of the unsigned number is like a signed number with the sign positive or negative hidden. Yeah. All right. So we can add an arbitrary number of digits. So here we can add 2 9s. Now we have a signed 3 decimal digit number, which can express from negative 999 to 999. We could do things like make this something more like a currency, and that's through the V, which indicates where the dot goes. And so now we can display between like negative 999.99 and 999.99. Yeah, so that's basically kind of numbers here in COBOL. It's all using decimal under the hood, and we can have signed and unsigned with a set number of fixed digits. There are more advanced usage clauses, which we could decorate this with, and that can basically inform the compiler to under the hood use binary numbers. So you can basically have something more like a U32, a U16, U8, S32, or like floating points, longs or doubles, those sorts of things, to basically use different instructions under the hood. Typically, those instructions are a little bit faster than the decimal instructions. But often with COBOL, you're running on mainframes, and they do have decimal instructions in their instruction set. Okay, so what about strings? We've been using 9 here for a number. So these are what are called numeric types. We also have alphabetic types and alphanumeric. And you can probably guess what these mean. So alphabetic, we could have something like name. And this is going to be basically a fixed width of chars. So you can say a pen. And this is basically just kind of a shorthand of saying we want, instead of writing A 10 times, we just put the number in there. So this is a buffer. We can initialize it with value spaces. And then down here in the procedure section, we can do something like display my name is name. And we don't see anything, but we can use the keyword quote before and after. And now we can see that basically we've got those 10 characters in there. And now we can do a move statement, which is basically the COBOL equivalent for assignment. And we can move Sean to name. Now we can see it in here. Notice that we've got a bunch of trailing spaces. So if we wanted to trim that, we have to use what's called a intrinsic function to do that. And that looks kind of like this. Notice how when you call the function, you have to use the function keyword before the name of the intrinsic. And now we can see it's trimmed down without those trailing spaces. Okay, cool. Yeah, so that's alphabetic. Alphabetic has the limitation where you can't put numbers. So you can't put digits in there. If I do something like that, I believe I should get an error. Yeah, I can't move 1, 2, 3 to name because it's alphabetic. If I quote this, it does work, which is kind of interesting. Let's declare a alphanumeric value, temp, and instead of a 9 for digits or A for alphabetic, we do X. And this time, the type system will allow us to assign a numeric literal to temp. All right. And then we're reading from it here. Basically, that's converting the numeric literal into the string representation under the hood. So we've got numeric, we've got alphabetic, we've got alphanumeric. Those are the primitive types. We can build structures called group items in COBOL. And then we can build up arrays. Those are called tables. I'm not going to get into that because it's a little bit more advanced. And I want to move on to some of the weird control flow stuff. All right, so procedure division. I mentioned earlier that you can have multiple procedures in here. The COBOL vision of a procedure is essentially defining a paragraph. So implicitly, we basically had one in here, and I'm creating something called main. And I can basically define other procedures here. Let's do say my name and change this back to my name. The statement to be able to terminate is stop run. And now you can see that we kind of start here. We implicitly go into the very first procedure, and we don't fall through beyond that because we had stop run. But we can go ahead and call, say my name by saying perform say my name. All right. And because all of the rest of these statements don't have a paragraph name. They're implicitly all here like this. If I wanted to break this out more, I could basically add other paragraphs. Let's call this do math. And I've got to terminate say my name with a period because every paragraph has to have at least one sentence. Okay, so now we can see we're executing this, but not this. You can do strange things with COBOL control flow. So I could do perform do math. That gets us to back where we were before. We could do perform say my name through do math. And control flow will go here. We hit the end of the paragraph, and instead of returning back to the caller, we fall through up until we hit the terminal paragraph we've identified here in this statement, which is do math. So we basically do all these, then we do all these, then we go back and then stop run. Yeah, you can think of this as a go-to with a return. So I mentioned before, we've got a hierarchy of things. So these are paragraphs. We also have something called a section, which we've kind of seen up here, like with working stored section. We can define our own sections of paragraphs as well. So this could be, I don't know, the Christmas section. And then instead of perform say my name through do math, if we do perform Christmas, it ends up basically executing all the paragraphs that fall underneath that. So you can kind of think about, if I were to indent this a little bit, you can kind of imagine that these fall under a Christmas section. If I were to add another section here, New Year's section. Now we just do this first paragraph. I think we can do perform Christmas through New Year's as well. Yeah. So we have basically a hierarchy of labels that we can target with perform. It could be sections, it could be paragraphs, things like that. Typically for modern COBOL, a lot of this gets collapsed down. So you don't really see sections. You might see individual paragraphs. Just for stylistic reasons, I'll just indent it like that. But you might also see additional structure. So in addition to having these procedures, we can also define a couple of other things. One of them is a subprogram. So we're inside of the hello program. And then down here, I can say end program hello. And this basically is the bottom of hello. I could down here define a sibling program if I wanted, which I could invoke. Yeah, so let's do that. Identification division program ID AAA. Let's add a procedure division display AA. End program AAA. Okay. So now we have two programs side by side. And up here in main, I could do something like call hello. Oh, I'm recursing myself. I'm calling the wrong thing. Call AAA, excuse me. All right, cool. So now we can see here that I'm calling the sibling program. So we can also define a subprogram, and that basically is having a program that nests inside of another program. And we do that by putting it within the definition of hello at the very bottom of the procedure division. So this is basically, you can kind of think of this as like hello, : AAA. That's kind of the opening there. And then here's the closing. We already have AAA. It's disambiguated because this shadows the other one. So if I change this to BBB, we'll see that this subprogram shadows the sibling, but we can change the identifier here to BBB. There we go. So now we're calling the sibling program and then the subprogram. The subprogram is basically only visible to its parent, and optionally it can be visible to sibling subprograms inside that parent. So if I define another subprogram, let's name this CCC. All right. And then up here, if I do call CCC, we should get an error. Yeah, undefined reference. But then if I go here, I can add this option. I believe it's is common. And now that basically makes this callable to the siblings. All right, so our subprograms are essentially the equivalent of inner functions, and they have basically the ability to access state from their parent. So things that are up here in the working stored section of the data division of the parent can actually be accessed. So for example, if we want to read name, we can go here to display CCC, and we can add name. Not quite yet. I think I might need to do is global. All right, there we go. So now, now we've got the ability to do that. We also have another way of passing state, and that's through using the linkage section. And that doesn't rely on this kind of subprogram parent program relationship. So we can basically have something closer to calling a function, and we do that by declaring our data division, declaring our linkage section, and then we basically have to define a type, and this ends up basically being a reference type. Let's pass the name. All right. And we use the keyword using name. And now when this gets called, we should have the ability to read name, but we have to actually pass that. Otherwise we get garbage. Notice here, this garbage, we've got to go to call AAA using name. And now we can see that comes through. So yeah, this ends up basically being a mutable reference to data. You can also specify a returning value. And there's actually a newer feature on more recent versions of COBOL, which gives value semantics. And that's actually not declaring a program ID, that is declaring a function ID. This kind of restricts what the program is able to do. And for functions, you basically have to move this up to the top here. A function is kind of like a mathematical function. So it requires returning a value. So we could add 2, and this is going to basically take pick 99, left-hand side, pick 99, right-hand side, and it's going to return results, which is also, which this will be a pick 999. All right, and now instead of using name, we have using LHS, comma RHS, returning result, returning. So add left-hand side to right-hand side. By default, that treats right-hand side as the destination, but I can do giving result. And now the result of adding left-hand side and right-hand side should be placed inside result. Okay, I need to, down here in the caller, declare some types. All right. So let's say move 55 to LHS, move 66 to RHS, and then we can do move function and the name of our function, add to LHS, RHS to result, and then display result. And we can see the result there, 121. That looks right. Cool. So one of the neat things about functions is the ability to use value semantics using by value should unlock the sort of optimization that you'd expect with a pure function with value semantics here. And down here, I don't think I need result. I think I can probably just do something like display. And I think I can then also get rid of result here. Cool. So we're passing now essentially, instead of a reference to LHS and RHS, the underlying value. And so then we should also be able to do something like this. And we get the same result here. So functions are pretty cool because we basically get to do kind of the normal expression style programming that we're used to in other languages. The calling convention of having to use function is a little bit noisy. We can actually get rid of that also by adding a bunch of extra data. We can add an environment, division, and then let's see if I can remember it. Configuration, section, repository paragraph. And it needs to be something like function add to, I think. And now I think when I've done that, we can get rid of that function keyword. Yeah, cool. So you could kind of think of that function keyword as being sort of equivalent to something like an STD namespace. It disambiguates what this COBOL word is to say that it's basically a function, but because we've predefined that up here, we can do the shorthand. Yeah, so I think that's probably enough for now. I might do some more COBOL videos in the future. Hope you enjoyed this.